back to another Daishinfinity video. In this video we're going to talk about the so-called Wi-Fi integral. This integral was very commonly used as a picture in social media. It got very viral, talking about this integral, and some people used to solve this and it was like in Instagram or any kind of other social media apps. And I saw this and I wanted to, just solve this thing because I didn't know the answer. Some people solved it. I saw the answer, but I wanted to do it by myself with my own methods. So today I'm going to use my own methods to solve this integral. So we have the integral from -2 to 2 of x to x cubed cosine x half plus 1/2 times the radical 4 minus x squared dx. Now, through the distributive rule, we can just split this up into two integrals using the sum rule of the integral. We're just going to say it's going to be the -2 to the 2 of x cubed cosine x over 2 times the radical 4 minus x squared plus, so dx over here, plus, now we're going to factor out the 1/2 out of the integral, and then we say -2 to 2 of the radical 4 minus x squared. Now the first part of the integral we can call this I, and the second part of the integral we can call it the Roman numeral 2. So let's do the Roman numeral 1 first. It's going to be the integral from -2 to 2 of x cubed cosine x half and 4 minus x squared dx. Now if we look at this integral, it looks kind of like a very complicated integral, and I think, yeah, with my personal methods I would use the DI method to go somewhere, but in general it's very difficult to solve this integral. So we have one thing in common over here. It's a very special thing. It states that if we have like an odd function, let's say like this function, and if we want to go from a point -a to another point a, it states that all the areas summed up together would be equal to 0 because the other half is just a negative of the right hand side over here in this integral. So this will be equal to 0. Now the property of an odd function states that f of x is equal to the negative of f of -x, because if we plug in negative numbers over here, it's just flipped upside down, so we put a negative sign on, so it's the same thing. So now, since we have -2 to 2, okay, we can plug in negative signs into this integral. So we would have cosine of -x over 2, -x to the third power times 4 minus x to the second power in parentheses dx. Now, as you see, the let's take red. The cosine of -x is the same thing as cosine of x, so this will be positive. The -x in the parentheses squared is going to be positive, so these are not going to change, except this one. -x to the third power will become -x to the third power, so -x to the third power. Now, since this is going to be true, we can take this negative and put it outside the integral, and we would have -2 to 2 x cubed cosine x over 2 4 minus x squared dx. Now this is just negative the Roman numeral 2, or like negative f of -x, and this is just the same thing as saying it's f of x. And since the properties of the odd functions are true, we can say that this is indeed equal to 0. Very nice. Now we're going to do the Roman numeral 2. I'm very sorry. Here I meant the Roman numeral 1, okay? So if we talk about the Roman numeral 2, it's going to be the half integral from -2 to 2 of the radical 4 minus x squared dx. Now there are many trigonometric ways to solve this. You can use trig substitution to do this one, but for the easy people here out, to make a circle, on the xy plane, we have a formula called the Pythagoras xy's. So x squared plus y squared is equal to r squared, for r being equal to any radius of a circle. Now if we let the square root of 4 minus x squared be equal to y, and we just take it to the second power, we would just get that y squared is 4 minus x squared. Add the x squared on both sides, so we get y squared plus x squared is 2 squared, 4. Okay, so we can indeed say the radius is 2. So since we have the radius 2, we can say that this is -2 and this is 2, since the radius is always constant. Okay, now if we take the integral from -2 to 2, half that integral, we would just get this area. But if we halve it, we'll get this area, or any area. We can get this area, or this area, this area, the absolute value of the areas of one of the 4. So the quarter area of a circle with radius 2. So if we would want to know the radius of the circle, we just have to go back to class 7, class 6 to know the area of a circle. The area of a circle is pi r squared. The revision of pi r squared is going to be in another video. And also pi r squared, plug it in, pi 2 squared, okay, is just going to be 4 pi. Now, since we have we don't have a full circle, we're just taking the half of the circle, so we just have to halve it. Now, if we halve 4 by 2, we'll get 2 pi. Okay, since we get 2 pi, the integral inside is, I'm going to write the integral again. This is just equal to 2 pi. Okay, now the 2 and the 1/2 will cancel out, and we'll get pi out.